Good afternoon, chemists. Welcome to week 16. Welcome back. Let's just start out. It was an amazing winter break. Food and family is really all I needed. Um, One very fun thing that my family and I did is we went to a sledding hill in Franklin, Wisconsin, and they had snow or glow in the dark tubing at night, and that was a lot of fun. How was your winter break? Looking back on the last like 2 weeks of break there, week and a half, like what stands out to you as like your like best moment of that break? It could just be even like the whole break felt relaxing. It could be I got to eat a certain food. It could be I got to hang out with a certain person. What if you feel so brave into the chat to chat out what you got to do that was very fun. So we had some food. Food is out of this world at holiday times. I don't know why. Just as playing video games. My oldest really did play some a good amount of video games herself and painted. Oh, that's awesome. Spending time with family and just sometimes the idea that you don't have anything to do and you can get up and just kind of go where the wind takes you that day is very freeing and relaxing, you know? I'm not sure. I think she did. She might have finished a painting because I know she was like hoping that someone was going to get her canvases for Christmas. You said it. A good boost before the end of the semester here. Well, Emily, I'm sorry to hear that you had a blowout with your friend. That always stinks. Yeah, hopefully in time you guys can resolve it. Sleep. Sleep is nice. I definitely could go for a really like good night's sleep. Mwah! I've been there, done that with some of my children for sure. Oh, Just Dance is so much fun. My daughters and I really enjoy doing that. We did that a lot actually during like the first part of quarantining. Yes, we did get snow. Now we are into our January gray days. Winter gray we're in. It was not the most fun snow to shovel either because it was very, very wet. There you go. You should walk to neighbors' houses and see if they'll pay you to shovel their driveway. All right. I am so happy that we got to have this conversation and hear about all of the different things that happened over break. Oh, very cool. Congrats to him. So let's just start talking about, let's transition over to our timeline here because now week 16 has started. We are back to reality, and that is the reality is this semester is ending. One, I cannot believe how fast this semester went, that it's insane to me, or incredibly insane to me, and how fast this semester went. And 2, we only have 3 weeks until the end of the semester. So this week and next week, we have 16 and 17. All of your work, though, for weeks 1 through 17 are due next week, Friday, the 15th. I will tell you that in chemistry, week 17, there is no new work, no new information that will happen during week 17. At our e-session, we will go through any questions that you guys might have about the semester in its totality, and we will go through the final activities that are planned for chemistry, and I will open up those activities, and you can begin to work on them during week 17 if you would like. And then we have week 18 are our semester activities, and they will be due on January 22nd. The 22nd then marks the end of our first semester. The second semester will then begin on the 27th of January. The final activities for chemistry are just like any other summative in this semester. So we have that timeline. I do want to let you know that Mr. Wozniak and I did, before break, update. Okay, come on, let's not. What the heck? Okay. I wanted to let you know that Mr. Wozniak and I did update our target grades prior to the winter break for you to be able to see where you are at. Him and I will try to update target grades again sometime this weekend or Monday, so that in week 17 and 18 you are well aware of where your grade is sitting at the moment. And I will tell you that if you go underneath this course information and the policies and click on our chemistry grading policy, currently my computer is spinning, so hopefully it'll pop up soon. There we go. Scroll all the way to the very last page, and what you're going to see here is a high school conversion chart. This conversion chart will let you know how your semester grade will transfer into a letter grade. This is considered a high school course, and so in all high school courses, your target grades will be converted into a letter grade, and so you are able to see what combination you guys have as your target grades, and then how that converts to a semester grade. Final activities, yes, I would be asking for you guys to complete them and to submit them. Just like I'm asking you guys to complete and submit all of the summative activities of this course. So you guys can see right here, so if you were to look to see where your target grade is right now, you would see that how it would transfer then to a semester grade. This will help keep you really informed as to what you need to do for the semester going forward. If right now you are in good standings, you know, it might not be worth all of the effort or time to redo any low grades, but if your target grades are low, you know, it might be worth your effort to do that. So I did want to point that out to you, that is in course information, and then you go to the grading policy. I did also want to share with you guys that Mr. Wozniak and I put out like an end of the semester. It's coming up. There are lots of feelings that happen with the end of the semester. People feel stressed. They feel anxious. They're trying to get work submitted. They're trying to get questions answered. And you have this kind of feeling of like, I need this to be done like yesterday. Kind of a desperate feeling to get things done, and a panicked feeling to get things done. And we wanted to keep it, you guys to keep in mind, one, please make sure that you are emailing your teachers, and please do it before you submit work. When you submit work and you put in like, I don't understand what's going on, so thus I did not do this work, doesn't help us help you. It's easier if you just email us that so we can square things away and then you can submit completed work. Please make sure that you know that we do have this 24 hours to respond back to you. So there is going to be a level of patience that happens with this at the end of the semester. Submitting, I'm really suggesting again that you do not submit just a link. Keep in mind that any work that you are submitting later on this week and any work that you submit next week, if you submit a link and we cannot get into your work, that it causes a little bit of an issue. And so I'm suggesting that you submit PDF files. If you want to do a PDF file along with the link, that's fine. And we put in here again how you do that. If you are working with a computer, if you are working with an iPad, how you would submit a PDF file to Blackboard. And just some ideas to help you guys, and maybe you guys can put in the chat some of the other ways in which you might help manage your feelings of stress or anxiety during this high time here. You can try taking walks. I know that it's a little bit on the cold side sometimes, but you can try taking walks, listening to music, just sometimes closing your eyes and listening to whatever music really just gets you in a better mood or calms you down. You can try doing some yoga. There's also meditation. Taking breaks. Really, I know it doesn't sound like, it's like, oh my God, I have all this stuff to do. I don't even have time to take a break. It's like, you can take a 10-minute break, a 5-minute break, and really just let your body come back to center. And sometimes by doing that, what you've been working on seems more clear to you, and then you are more efficient at getting things done that need to get done. Drawing, writing, oh my gosh, perfect. Here, we can just go like this and edit. I knew you guys would have some better ideas or some more ideas than what we came up with. It would help too if I could spell. There we go. Yes. Very cool. Very good ideas. I knew you guys would be really good at sharing with your classmates some other things to do to make sure that you guys are managing your stress or feelings of anxiety. Really, these taking breaks goes along with what Moses was saying is when you are present in the moment, you can be doing your work in a very efficient way with not very many distractions. Once you feel like you're losing that focus or you're starting to get more distracted, that's your cue possibly to be able to take a 5 to 10-minute break, try one of these things on this list, or try something that your classmates have just listed above. And for 5 to 10 minutes, really just let your body do that and take a break. And when you come back, you will be more focused again and be able to, again, efficiently get work done. It really does help. And I know it seems a little counterintuitive when you feel like you have a lot of things that need to get done on a list for you to pause, but 5 to 10 minutes sometimes is all you might need. So please make sure that you are managing that stress, that anxiety level, that kind of high intensity time that we are going to begin entering. This time might be more intense for some of us than it is for others. Some of us might be feeling pretty good at where you are for the semester, and some of us might be feeling like you have a lot more work to get done. So again, if you are really struggling or having trouble, please make sure you reach out to myself or Mr. Wozniak, and we certainly can try and help you manage and or alleviate some of that stress with, setting up a schedule or, giving you exact things that need to get done before the deadlines. Okay. Any clarifying questions about the timeline that we have going on here for the next 3 weeks? Any questions about, how to manage your stress or how to submit work or anything of that nature? I'm just asking if there's any clarifying questions about what we have been talking about, a timeline, um, with the last 3 weeks, when work is due, how to find where to convert your grades, how to manage stress in this kind of stressful time we're going to be entering. All right. So let's get into then what we have going on for week 16. As I had mentioned to you guys before, that week 16, this is our last week that we have for to learn more information about our chemistry here. I'll just share with you really quickly that if you look at week 17, it is really just a last call. There is no new work. And it really is just a time for you to reflect and look at where you are in chemistry and what needs to be done. And I will also at week 17 will open up the final week activities. For those of you that are ahead, you can begin to work on those week 17 activity during week 18 activities during week 17. So week 16 here is all about chemical reactions. We do have different types of chemical reactions. The first thing that you are asked to do is we do have some reading pages here. These reading pages are on a document. Keep in mind that I know it looks small, but you can, zoom in and you can read. So you have this option. We do have a couple pages here about chemical reactions, all the different types of chemical reactions. And we did give you a template for your notes. And it looks like the reading is linked in here as well. But we did give you some essential questions and some practice problems to do about chemical reactions. We have a fun video on chemical reactions, a way to start remembering what you're looking at and how these chemical reactions, or what's happening within these chemical reactions. Next semester, we will explore these chemical reactions and how we predict and know what's going to happen. We did give this student activity for you guys. Properties, examples, things that you saw within the video. And then we have our last summative, or our second to last summative, and this is everyday chemical reactions. So for this assignment, we are asking that you consider how and where and how you interact with chemistry in your daily life. You should provide a list of chemicals that you find in your home. Be sure to list 5, more than 5, but less than 15, so somewhere in there. Then do some research on those products and those chemicals that they contain. Include both the common name and proper name of the chemical, the common name and proper chemical name when possible, the chemical formula and the formula mass for it, and discuss how they chemically function to do their intended job. Consider such chemical reactions as to how you heat your home, how chemicals that are in your kitchen, cleaning agents, and then create a Word document and submit the link above. So that is your second to last summative for this semester. You could do baking soda, sure. At this point, Samantha, you don't need to show anything with a chemical reaction. We're really just introducing chemical reactions right now, and we will learn how to write them and how to read them next semester. You could just take the main ingredient of baking powder if you would like. Absolutely. When you cook food, you are chemically heating and altering some of the ingredients. Yes. Well, Samantha, you would have to look up. Some people just write down like bullet point, write down what they do. So like, when you use baking soda or baking powder and you're utilizing these things in like a dough or a like cooking a cake or cooking cookies, like there's a chemical reaction that happens with them that causes these things to help them rise or to fall or so you would just you could do this in a illustration, you could do this bullet point. I'm not asking you to write a chemical reaction or a chemical equation. But yes, you would essentially with words explain the chemical equation that's going on. So like there's a reason why we use baking soda, there's a reason why we use baking powder in baking and in cooking, mostly baking. There's a function that eggs will serve to it sometimes. So some people will put eggs, although it's not a chemical. Yep, you got it, Eleanor. Good job, Samantha. Yep, you could do a mini paragraph description. Some people just bullet point what they do. That's fine too. Okay, good. Mr. Wozniak and I were really just wanting you guys to start realizing that you do interact with more chemicals than what you think. And we just want you to start thinking about how these chemicals do react and what are some of the things that they do when they react, because we are obviously talking about chemicals reacting or in a reaction. And again, just really exploring this idea and recognizing that it happens quite a bit around us. And then we can take that into next semester when we fully investigate these chemical reactions and we start predicting the products of them and we start working with some of the math that is behind the equations. There is not a certain amount you need to do in order to get advanced. We were just asking anywhere like probably 5 is your minimum, 15 would be the maximum. Anything over 15 is a bit overkill. And I would echo what Moses says. Yep, you just do the ones you're doing very well. We prefer that over a lot done not very well. Quality over quantity, yes. He got you, Lucas. Are there any other clarifying questions about what is expected of you this week for this week 16? All right. Okay, so at this time then, if you feel pretty confident about what is happening during week 16 and you are want to leave the e-session, you are more than welcome to leave the e-session. If you would like to stay in the e-session, we are going to work on the video and chemical reactions. I'm going to put this into the chat. If you want to stay, then I ask that you click on that, make yourself a copy. Actually, just click on it. And I'm going to put about 1 minute on my timer so that it allows you to get ready, or if you'd like to leave, you can leave. We will cover combustion reactions, yes. We're not going to like watch any of them happen, but we will definitely cover them. Yep, we'll go through them. All right, so at this time, we are going to go through the reaction notes. We have single displacement, double displacement, combustion, synthesis, and decomposition. And Samantha is right that the video doesn't necessarily go through combustion. So we're going to start with combustion, and then I'm going to have you guys add notes about single displacement, double displacement, synthesis, and decomposition as we go through the video. I gave everybody editing rights to this document so that as we are watching the video together, you guys can be adding notes here. When we do add notes, I'm just going to do bulleted notes. I really like the way that those look and think they're easy to follow, and it's especially easy when you have a group of people adding their own thoughts to it. So combustion reactions are probably the most fun reaction because when people come into chemistry, they ask, are we going to blow anything up? And people associate things blowing up with chemical reactions, and those things blowing up, it would be a combustion reaction. What are some things that you guys might already know about a combustion reaction? Yep, you need a fuel like oxygen, so You need some sort of heat or something needs to happen there. Does anyone else know anything about combustion reactions? There are other things, but generally oxygen is associated with a combustion reaction. Typically, you would have some sort of um, accelerant, and when you add oxygen to this accelerant, then you are going and heat or some sort of something to get these things moving together, and then you would generally give off like a light. But yes, oxygen is very typical and the most widely used in a combustion reaction. It is really considered a reaction of burning. A lot of people in their minds will think of like a combustion where you're seeing like a big fireball happen. But anything really, anything burning is generally considered combustion. Anything else that you guys know? I'm going to put this word rapid. It's a rapid burning, a rapid. It generally does happen pretty fast. And so we usually have this idea of so we usually have this formula of something here plus oxygen, and then we will always get carbon dioxide and water, and typically this is going to be some sort of carbon compound. Is typically what you would see as this first reaction or reactant here. That's right, Samantha. Yeah. So like, if you want to really get into like a next step of chemistry, you're talking about oxidation, like reduction. So like your rusting is considered to be like combusting because your iron is reacting with oxygen. When you set that on fire, yes, it's quote unquote rusting even faster or moving even faster. So a combustion reaction is definitely a rapid form of oxidation reduction reactions, which generally look at oxidation reduction more in an advanced chemistry class or an AP chemistry class. But very, very good. So those are properties of these combustion reactions. And so now what I'm going to ask you guys to do. How many do we have in here? We have 7 of us in here. So we have 1, 2, 3. No worries. So what I was going to ask for you guys to do is underneath the reaction that you want to watch for, put your name. So like you would put like, I would put like Mrs. Wolf, and I am going to just keep my typing in black. You can change your font color. Please stay away from these two. Type your name underneath which reaction you are going to look for in this video and take notes on. and put your name underneath it, put what color font you would like to use. And while you guys do that, I am going to yeah, I can make it full screen. Okay. I'm going to get this movie ready to go. I'm just waiting for you guys to put your name underneath which reaction you would like to watch for. And what color you'd like to type in. We can have more than one person. Everybody should be able to edit. Yep. So here, I will send the link out again. There we go. Yay, there it is. Now I'm seeing people. All right, Tristan. All right, I do not want Tristan to be the only one that is going to work on this together. So let's get some other people here. My gosh, people are leaving like crazy. So let me just ask them really quickly. So Ariana, Eleanor, Emily, Joe Mary, do you guys want to do this, or would you guys prefer to we be done with the e-session at this time? Okay, Eleanor, then you got to put your name underneath which one that you want to help with those. I'll just put your name for you. Emily, I understand that you're auditing. However, you can still participate in the class, and that's okay. Thank you, Eleanor. Ariana and Joe Mary. That's all right. Let's get going here. Otherwise, we are not going to have enough time.
Classifying chemical reactions with the Flintstones. If Fred were to go to a dance and he were to meet Wilma, Fred and Wilma would combine together and form the Flintstones. This is called synthesis. When substance A is added to substance B and you get a combined compound of AB,
All right, so there's our first one. There you go, Tristan, very good. So our first one is synthesis.
You have created synthesis, similar to when hydrogen and oxygen bond together to form the molecule water.
So synthesis is, and I'm just pausing so that Tristan has enough time to put an example, like a real example, not the Flintstones. So synthesis is whenever you're taking one, like two or more elements or compounds, and you are putting them together to create one product. So you see that we have one product here, which is just water. Or you had Fred and Wilma together, and when they were together, they were dancing together, they were one. And so that is the synthesis. Synthesis is the making of something. So you have two or more reactants with one product.
The synthesis of water. If, however, the Flintstones were together and they got a divorce so that Fred was on his own and Wilma were on her own, then you have decomposition. A compound breaks down into its component parts. AB yields A plus B. This happens in the decomposition of potassium chlorate, when KClO3 breaks down into KCl, potassium chloride, and oxygen gas.
All right, so I'm just going to go like this. So decomposition is anytime we are taking one product, one reactant, and we are splitting them back up into their individual elements or into more than one compound. So here we're using the Flintstones of Fred and Wilma are together, they are one, and now they are not one, they are separate, again causing that to be decomposition. And here is an example of that. We have potassium chlorate, one thing here breaking up into multiple different elements and or compounds.
Decomposition of potassium chlorate, when KClO3 breaks down into KCl, potassium chloride, and oxygen gas. If, however, the Flintstones went to a dance and they met up with Betty, and when Betty showed up, she ended up with Fred, leaving Wilma by herself, we would call this single replacement. We are replacing one part of the pair. So AB plus C gives off AC plus B. We are replacing one part of the compound.
All right, so single replacement, or sometimes also known as single displacement, I've seen it both ways and heard it both ways, is when you have one compound plus a single element, and in the reaction what happens is that this single element will take the place of another element in the compound, making a new compound with one single element left over. So in this real life reaction here, we have a compound and a single element. We have a new compound with a new single element. So in this case, silver or copper knocked silver out, and now silver is by itself.
This is called single replacement, and this happens when silver nitrate combines with copper to create copper nitrate and release silver. And our last type of chemical reaction is a double replacement. That's if the Flintstones went to that same dance, and there they met the Rubbles. And while they were dancing, Fred ended up with Betty, while Barney ended up with Wilma. In this case, we are exchanging two partners, this being double replacement. AB compound breaks down along with CD compound, which breaks down, and you end up with compounds AD plus CB. An example of this would be a double replacement reaction where potassium nitrate combines with magnesium chloride and ends up being magnesium nitrate plus potassium.
All right, so in this case, we are swapping partners. So we have two compounds that are together, and we make two new compounds with a swapping of partners going on as they break down. And here's the real life example of that.
Chloride. This is classification of chemical reactions, and thank you to the Flintstones. Classifying chemical reactions with the...
All right, let's... All right, perfect. So I'll just add to this quickly. I know I was trying to give enough time, but I couldn't see how you guys were typing. Uh, all right, perfect. Okay, so those are the different types of reactions. This is our little excerpt into it, our exploration into it, and then we will carry this over into next semester and really look at all of these. At this time, I don't have anything else for our e-session. I wish you all a lovely week 16, and we'll see you guys back here next week, Wednesday, for week 17. Have a good week, guys.